We can really deliver temporarily changing stimuli to cells within the testbed and maybe do some very interesting biological experiments.
I recently had the opportunity to chat with 5 early career researchers about their exciting practical work in molecular communication. This was in Erlangen, Germany for the 2023 workshop on molecular communications. It was a great workshop, and one of the most exciting activities was an experimental testbed session. The researchers I spoke with were all presenting at the session, and in this series of videos I'm sharing what they had to say about their presented work, how the technologies could be used in applications, and what they'll be working on next. This video features Stefan Angerbauer from Johannes Kepler University in Linz, Austria. Stefan presented a testbed that uses salt concentrations to send messages that are measured with a conductivity sensor.
My name is Stefan Angerbauer and I'm from the JKU in Linz. And my testbed is on salinity-based molecular communication. The basic idea here was that we want to use salt as a signaling molecule due to the fact that it is biocompatible, it is non-toxic, and so on. So we wanted to examine how good is salt in order to communicate within the human body. And in the first step towards achieving that final goal, we built this setup. We have 2 pumps, one pumping regular water, the other one water with salt added and also with color added, so that I can distinguish what is salt water and what is regular water.
They look so similar, right?
Exactly, yeah. So, and then we have these pumps, and these pumps regulate the flows into the microfluidic channel. And by changing the ratio of salt water and regular water, we can encode different salinity levels. For the demonstration that I showed, this was encoding 4 levels, but we could even do more than that. And this information then is transmitted across our microfluidic chip that we also manufacture ourselves. And then we recover the information by a salinity measurement, and therefore we utilize the fact that for water, the salinity depends linearly on the conductivity or vice versa. So by measuring the conductivity, we can recover the levels, and by recovering these levels, we can recover the information transmitted. The testbed is a first type of interface. So you get into the body with a syringe, and you get out of the body by measuring some value, in that case, the concentration of ions, or more specifically, the salinity. So this is like a first work towards that direction. In a currently ongoing work, we have already shown what happens when you have stronger intersymbol interference, when you have weaker signal amplitudes, and so on. Maybe at this point I also should mention that we have a journal preprint already published that is, I think the working title is Salinity-based Information Transmission in Microfluidic Channels. So it's already available, and there we did also really the in-detail modeling, and we examined the influence of different parameters of the setup, also in order for the user of the setup to maybe tailor the setup to their needs, more or less. So that's basically the information that we currently have about the setup. In the future, the goal will be to work towards doing these experiments also in the human or animal body, and see if it is possible to use this as a molecular communication method to safely transmit informations into or out of the human body. To me personally, the most interesting thing about it is that we have really a detailed model of it. So for me that's interesting, because now, as I said, we can really predict what would happen if you change different parameters of the setup, and we have verified almost all of it experimentally. So we have a very deep understanding of what the testbed is doing, and this is especially for me important to, if we want to go to further applications, to really understand the basics and have a solid knowledge base from which on we can now build up our future applications. And communication-wise, the most interesting thing is that we do multi-level transmission, that we can in principle set the salinity waveform, if you want to call it like that, so like the temporal profile, more or less continuously. So we are actually not restricted to have our 4, 6, 8, whatever levels, but we can really vary it slowly over time. And this is also maybe also an interesting outlook if we have cells within the testbed. This is something that we're currently researching on with a partner. Then we can really deliver temporarily changing stimuli to cells within the testbed and maybe do some very interesting biological experiments. So I'd say the most interesting thing is that we understand it quite well, and that we now have a solid knowledge base from which we can build future applications, medical or IOB and T devices. That's more or less the goal. So to, on the one hand side, have this testbed and see it as a starting point for our research, but we definitely also hope to influence other researchers. At the end of the day, the testbed is also quite cheap, so all in all you would pay probably 150 euros for it, maybe a bit more depending on how good your retailers are. But at the end of the day, that's it. And so it's quite cheap, but it still allows a great flexibility, because we also published the manufacturing method, so you can really experiment with different channel geometries, you can experiment with different pressure ranges, dimensions, whatever you want. This is, like, as I already said, really like the starting point, and hopefully also other members of the research community will maybe rely on that. My background is actually mechatronics, so I'm not a typical comm engineer. In my bachelor's, I focused on mechatronics, but with a special focus on electrical engineering, which you also see in the testbed, because like the measurement circuit was, for example, designed by me. In the master's, I actually did quite different direction. So still mechatronics, but now with a focus on system analysis and optimization. And in parallel, more or less, like that was my master thesis, AI-based control, and also the majority of courses on AI, like, supervised, unsupervised learning, or neural networks, all of that. And we are trying to incorporate more or less all of that knowledge now into the testbed. And maybe for the PhD now, the topic is actually interfaces for the Internet of Bio-Nano Things. Okay.
Great, thank you very much, Stefan.
Thank you.
That's all for now. Thanks for watching. You can like the video and leave feedback in the comments. I will be sharing more conversations from the 2023 workshop on molecular communications in a later video, and these will be combined in a playlist. Consider subscribing to stay up to date with releases, or if you'd like to see more research highlights and tutorials on biophysical communication engineering. See you next time.